College Algebra topic lesson 1.5, factoring polynomials, part 2. Okay, this time we'll be factoring trinomials. And when we factor trinomials, the first rule is that trinomials always used to be two binomials before multiplication. So let's start off with this. The way that we factor trinomials is first we start off by writing two binomials, and then we factor the first term and the last term. The first term, 2x squared, we can factor that into 2x times x. Now, the second term, 15, we can either factor that in 5 times 3 or 3 times 5. I'm going to choose 5 times 3. Now, to see if this is correct, whether it's 5 times 3 or maybe 3 times 5, I'm going to use the inner and outer of FOIL to find out. So I'll multiply these two and get 5x, multiply these two and get 10x. Now, once I've got the 5x, sorry, this will be 6x, the 5x and 6x, this sign right here tells me that both signs need to be positive. So, sorry, both signs need to be the same, my fault, same, either negative, negative, or positive, positive. So can these two signs be the same and get a 13x? And the answer is no. These signs cannot be the same, according to this sign right here, and give us a 13x. So I'm going to try this again. 2x times x again, but instead of 5 times 3, I'm going to try 3 times 5. Inside, this will give me a 3x, and on the outside, this will give me a 10x. Now the question is, can the signs be the same and I get a 13x with these? And the answer is yes. If I have both of these positive, I will get 13x. So positive, positive belong here and here. And this is what this trinomial used to be, these two binomials. Okay, let's try it again. Number 2. Okay, we have a trinomial. We assume trinomials used to be two binomials before multiplication. So, first I factor the 2x to the 4th. So I say 2x squared times x squared. Now for the 15, I don't know whether that used to be a 3 times 5 or 5 times 3. Let me try 5 times 3 and see what happens. 5 times 3. So in the center, we'll get 5x squared, and outside we'll get 6x squared. And this tells me my signs need to be the same. So if my signs were the same, could I get an 11x squared? And yes, positive and positive will produce the 11x squared. So positive, positive goes here and there. So this is the original binomial. Number 3. This is a trinomial. Let's factor this into two binomials. And again, we start by factoring the first and the last. The first, factoring the 2x to the 6th power, we'll say that used to be 2x to the 3rd times x to the 3rd. The 15, let's say that used to be 5 times 3. 5 times 3. Now, a negative means the signs need to be different. So let's multiply here. So we have 5x to the 3rd, and here we'll get 6x to the 3rd. Question, can the signs be different here and here and get a negative 7x to the 3rd? And the answer is no. So now I'm going to try the 2x to the 3rd again times x third, but instead of a 5 times 3, I'm going to try 3 times 5. This will give me 3x cubed here, and this will give me a 10x cubed. And the question, once again, can the signs be different and we get a negative 7x cubed? And the answer is yes. If this were positive and this were negative, the signs would be different and we would get a negative 7x cubed. So our signs need to be positive then negative, positive then negative. Okay, number 4. We have another trinomial. We're going to factor this into two binomials. 2x to the 8th, y to the 4th, we're going to factor that into 2x to the 4th, y to the 2nd, times x to the 4th, y to the 2nd. Now, the 15, I don't know whether that's 5 times 3 or 3 times 5, but let's try 5 times 3. See if that works. Okay, so, and the signs will need to be different. So, inside, I get 5x to the 4th, y squared. outside, I get 6 x to the 4th y to the 2nd. Now, if the signs were different, could I get a positive x to the 4th y squared? And the answer is yes. If this was negative and this was positive, I could get the positive x to the 4th y squared. So my signs would be negative, positive, negative, and positive. Next trinomial will be number 5. Number 5, I'll factor this into 2 binomials. So first I'll factor my 2x squared into 2x times x. Then I need to factor my 15y to the 4th. Let's try 5y squared times 3y squared. And my signs will need to be the same. So when I put these together, I get 5x y squared, and I also get 6x y squared. And I noticed that my signs, if my signs were the same, I could not get a negative 13xy squared. So instead of a 5 times a 3, I'm going to change this into a 3 times a 5. This will instead give me a 3xy and a 10xy squared. If my signs are the same, to get a negative 13xy, I would have to have negative negative. So negative negative goes here and here. And this is the binomial that this trinomial used to be. Or these are the 2 binomials that this trinomial used to be. Next, this is a trinomial. Trinomials factor into 2 binomials. First, let's factor the 1. The 1 used to be a 1 times 1. That's not bad. Well, what about the 20x squared y squared? Well, let's say that used to be a 4xy times a 5xy. And the signs are going to be different. So when we multiply these two, we'll get 4xy. When we multiply the ones on the outside, we'll get 5xy. And if the signs have to be different, how do we get a negative xy? With a positive 4xy and a negative 5xy. That'll give us our negative xy. So positive, negative, positive, negative. Okay, well, number 7, we see that this leads with a negative. That means that originally someone must have multiplied this by a negative. So we have to reverse that first and then factor it back into 2 binomials. So this used to be a negative times a positive x squared, a negative 5x, and a negative 2. So originally this used to be a negative times this trinomial. Now, before that, it used to be a negative times 2 binomials. The 3x squared, we can factor that into a 3x times x. And the 2, we can factor that into a 2 times 1. The signs need to be different. So let's look at that. So 2x, and outside we have 3x. Can the signs be different and get a negative 5x? And the answer is no. The signs cannot be different and get a negative 5x. See, that will not work. So instead of a 2 times 1, let's try 1 times 2. The 1 times 2 will give us 1x and a 6x. And we want the signs to be different to get a negative 5x. So I'm going to use a positive, negative, and this will give us the negative 5x. So positive, negative, then negative. And this is the original factors before multiplication. Okay. For number 8. Number 8, it leads with a negative, therefore we want to remove the negative first and say that this used to be negative times a positive 3x to the 4th power, positive 7x to the 3rd power. I think that should be a 2nd power. And then positive 2. Then this trinomial right here used to be 2 binomials. So 2 binomials. And now I'll factor the 3x to the 4th. That'll factor into 3x squared and x squared. The 2, let's factor that into a 1 times 2. 1 times 2. So in the middle we have a 1x squared. Outside we have a 6x squared. And this tells us that our signs need to be the same. So to get a positive 7x squared. And we can't have positive. So positive here, and this was our original binomials and negatives. That gave us the negative 3x to the fourth minus 7x squared minus 2. Now we'll be factoring completely. We can factor the number 12 into what it used to be. You say 12 used to be a 6 times 2. The problem is that 6 used to be a 3 times 2. So originally we would say 12 used to be a 3 times 2 times 2. This is complete factoring, whereas this is incomplete factoring. So we're going to factor these completely into what they used to be originally, all the way down to the prime factors. We always start this process by looking for GCFs. So this is a trinomial, and I want to return it to what it used to be before multiplication, all the way down to prime factors. The GCF for this one, you have 8, 12, and 4, would be 4. Also, it ends with an x, so the GCF is 4x. So this used to be a 2x squared plus 3x plus 1. So this trinomial used to be a monomial times a trinomial. Now this trinomial used to be 2 binomials. And I can factor that by saying 2x squared can factor into 2x times x, and 1 can factor into 1 times 1. Here in the middle, I get 1x and 2x. And my signs need to be the same in order to get a 3x. So plus plus, so I get plus plus here. So this polynomial used to be a monomial times 2 binomials before multiplication. Here we have a trinomial. First we look for any greatest common factors, or GCFs, and there are none. So I'm going to start attempting to factor this into 2 binomials. So 3x to the fourth, I assume that used to be a 3x squared times x squared. The 2, let's say that used to be a 2 times 1. 2 times 1. And now my signs have to be different, so let's use the 2x squared and the 3x squared. We're multiplying these two and then these two. If my signs were different, I could get a negative x squared by using a positive 2 and a negative 3. So positive, negative. So positive here and a negative there. So this trinomial used to be 2 binomials. But this binomial right here is a difference of 2 squares. Again, I can use a square root on both terms. Therefore, this binomial used to be 2 binomials before multiplication. So this used to be 3x squared plus 2. This used to be x plus 1 times x minus 1. So this trinomial used to be 3 binomials before multiplication. Okay, here we have a binomial, and it looks like it's a difference of 2 squares. If everything can be simplified with the square root, then we can factor this into 2 binomials. So let's give that a try. The square root of 16 is 4, the square root of x to the fourth is x squared, plus the square root of 81 is 9. So everything's simplified. Therefore, the conjugate, which will finish the binomial, should be 4x squared minus 9x. So this binomial used to be 2 binomials. But this binomial is also the difference of 2 squares. So this binomial used to be 2 binomials. And so when I factor this using the square roots, this reduces down to a 2, x, and plus 3. The conjugate of this will be 2x minus 3. And now there are no more differences of 2 squares, and this is as far as it can go. So this binomial used to be 3 binomials multiplied before. Okay, problem number 4. We want to factor this trinomial, and we notice that there are no GCFs in here, so we're going to factor this into 2 binomials. We'll start by factoring the x to the fourth to x squared, and then we want to factor the 36. There are many ways to factor 36. 6 times 6, but this will give us 6x squared and 6x squared, and if both sides were the same, we could not get a 13x squared. So I'm going to try 4 times 9. With 4 times 9, I get a 4x squared and a 9x squared. If the sides are the same, right here, it will give me a negative 13x squared. Alright, now from here, you'll notice that this is the difference of two squares. This is also the difference of two squares. So this will factor into two binomials. And this will also factor into two binomials, which will be conjugates. So this will be x plus 2 times x minus 2. This will factor into x plus 3 times x minus 3. So this trinomial before multiplication used to be 4 binomials. Number 5, we have a 4-term polynomial. There's no GCF in the entire problem, so instead we're going to use the technique of see if we can take GCFs out in groups. So the GCF of the first two terms will be x squared. So this is x squared times x plus 1. The GCF for the next two terms would be a negative 4 times x plus 1. Now we have common terms here, so we can take these out as the next GCF, which will be x plus 1 times x squared minus 4. So now we've turned this 4-term polynomial into two binomials. But this binomial is a difference of two squares. So I can factor this into conjugates as well. So this will be x plus 1, and I will get two binomials out of this difference of two squares, which will be x plus 2, taking the square root of both terms, times the conjugate x minus 1. So, factoring completely, this 4-term polynomial used to be 3 binomials before multiplication. Okay, here again, we have a 4-term polynomial. We start the process by looking for GCFs, and we do have them. 3, 6, 3, and 6. The greatest common factor is 3. And it also is in descending order ending with the x, so x is the GCF. So dividing each one of these by 3x, I get x to the third minus 2x squared minus x plus 2. Alright, now this is still a 4-term polynomial, and I've removed all the GCFs out of the incomplete problem. I want to try my technique now of taking GCFs out of just the first two terms and those two terms. So this will be 3x, and let's introduce a bracket here. So I can factor out an x here, x squared, leaving behind x minus 2. Here my GCF will be negative 1, so negative 1, and factor out, I'll have x minus 2 again. Okay, now I have GCFs. I have GCFs of x minus 2 and my GCF of 3x. I'm going to pull all GCFs out to the outside. So I have my 3x and my x minus 2. All the GCFs are outside here, leaving behind the x squared minus 1. 1 minute. Videotape. From there, I'm going to take my 3x and x minus 2. I'm going to factor my x squared minus 1 into x plus 1, x minus 1. Because again, this is the difference of two squares. And what this tells us is that originally this 4-term polynomial used to be a monomial times 3 binomials. Okay, I want you to do the last problems on your own. Number 7, x to the 6 plus 7 over 2x cubed plus 3. Back to this. Also number 8, 3/4 x to the 4th power minus 5 over 2x squared minus 2. And finally number 9, 2/3 x cubed plus 2/3 x squared minus 3 over 2x minus 3 over 2.